Kia ora, Year 12. This is the third partial fractions video, and in this one we're going to look at problems like this one. So write this expression as the sum of partial fractions. So before we get into that, on the bottom of the screen down here, I'm going to put an easier problem. So this is the type of thing we've had until now. Now let's just take a look at this bottom one first. What have I got here? Well, the order here of this denominator is 2. It's a quadratic, right? But the order here is just 1. It's a linear factor. So until now, we've been looking at situations where the order of the numerator is lower than the order of the denominator. In the problem we've got up here, we've got a quadratic in the numerator and a quadratic in the denominator. So before we get into the easy way to do these, let's think about how we could do them using the methods we've got till now, because they will still work, they're just not very efficient. We can factorize the denominator, and then we can split it up. We split it up into the x and the x minus 2. Now, because I have to generate a quadratic, if I just have an a and a b, that's not going to give me a quadratic, because when I multiply through to get my single fraction numerator, I'm going to have an ax minus 2a, and when I multiply through here, I'm going to have a bx. But nothing is going to give me that 3x squared. So that means that what I need to do instead is to have a linear factor for one of those. So let's see if I can do the erasing thing. Yep, we can. So instead of having a and b here, what I need to have is ax plus b plus c. So that problem immediately becomes more painful to work through. But now if we take a look at this first one here, I can rewrite that as a plus b over x plus c over x minus 2. So what that's telling me is that when I've got a partial fractions problem in which the order is the same for the numerator and the denominator, I'm going to start with a numerical value here. Right, so this is going to be, it won't always be an integer, but it'll be a fraction or an integer. But it's easiest if we get that out of the way first. So in the next couple of slides, I'm going to work through this problem quite slowly and then give you a couple more to try yourself. Okay, so we've got 3x squared plus x minus 4 over x squared minus 2x. So we want to get the constant factor out first. So we're going to rewrite it like this. 3 times x squared minus 2x. So what we're doing here is we're generating a factor of x squared minus 2x on that one there. So we're going to try and get a 3. So this should feel a little bit like when we learned how to do completing the square. What have I done in here? Well, I've got my 3x squared, but now I've taken away 6x. I'm going to add that back in now. Right, so this now gives me the 3x squared plus x minus 4. Some of you will have faster ways to do that in your head already. That's great. I recommend for the first few when you're practicing these that you do step pretty carefully through. So what do we have here? We've got 3 times x squared minus 2x plus 7x minus 4 over x squared minus 2x. And that now gives me 3 plus partial fraction problem that looks just like my old ones. Okay, so we now do a second step of the problem, which is to say 7x minus 4 over x times x minus 2 is equal to a on x plus b on x minus 2. So working with the numerator, 7x minus 4 is equal to a times x minus 2 plus bx. And we'll use the substitution method here to work out a and b. When x is 2, we get 7 times 2 take away 4 is equal to 0 plus 2b. That gives me 10 equals 2b. B is 5. Substituting in now x equals 0, I get 7 times 0 minus 4 is equal to a times negative 2 plus 0. Right, the 0 is coming from the substitution in there. That gives me negative 4 equals negative 2a. A is equal to 2. So we can write up our final solution like this. 3x squared plus x minus 4 over x squared minus 2x is equal to 3 plus 2 over x plus 5 over x minus 2. Right, so remember the general strategy is that if we've got a problem in which the orders are equal, we divide out first to get the constant term, the plus 3. Right, the next example I'm going to do is one in which we're going to start where the order is greater in the numerator, but it's exactly the same idea. Okay, so the harder problem that I want to look at is this one. I've got a cubic. I've made this one up specially for today. 4x cubed minus 3x squared plus x, that's a plus, minus 13 divided by x squared minus x minus 2. Now if you think about that for a minute, you'll realise that we're going to have to get some kind of linear factor here because I've got a 4x cubed and I've only got an x squared down here, so I'm going to have something times x, and it's going to be 4, right? And then I'm going to have my partial fraction set up here. And factorising that denominator, we get x minus 2 and x plus 1. So it looks like it'll be something like this. Now you can muck around doing the kind of working everything in the numerator here. So you can take out your 4 like this, and then you can do your adding back in the stuff you took out method. And that's how we did the last one. Whoops, that should be 4x. Sorry, 4x. What a mess. 4x times all of that. But you can see already that the chances that you make a mistake doing it that way are quite high. So when you've got one like this, the best thing to do is to go straight to polynomial long division. And hopefully you all remember that, but there is a video on my level 3 calc channel if you've forgotten. So we're going to jump straight into that now. So we've got x squared minus x minus 2 here, and we've got 4x cubed minus 3x squared plus x minus 13. Right, so off we go. We've got x squared times what will give me 4x squared, so matching on that we're going to get 4x. So 4x times all of this gives me 4x cubed minus 4x squared minus 8x. Right. Taking that away to work out what the leftover is, minus 3 plus 4 gives me x squared. X plus 8x gives me 9x minus 13. Right, matching now on the x squared, we get plus 1, try and keep the same colour, 4x plus 1, multiplying through, and see how nice and clean this is compared to the keep it all in the fraction approach. So subtracting that, x squared minus x squared gives me 0, 9x plus x gives me 10x, negative 13 plus 2 gives me minus 11. So we're nearly there. On the next slide, we're going to write that out in fraction form, and then all we have to do is our easy one-step partial fraction method. So what have we shown so far? Well, we've got 4x cubed minus 3x squared plus x minus 13 over x squared minus x minus 2, which we can write as 4x plus 1. Right, so that's our linear factor, plus, what have we got left? Well, we've got x squared. Whoops, hang on, we don't have x squared. We got rid of that. No x squared. We've got 10x minus 11 over x squared minus x minus 2. So that's 4x plus 1 plus 10x minus 11 over x plus 1, x minus 2. Right, so pause the video and go quickly as fast as you can if you've got these ones down well. Work your way quickly and accurately through that problem. Okay, so here's what you should have done. We've got 10x minus 11 equals a times x minus 2. This is an identity, and so are all these. So for any value of x, this will be true. Using our substitution method, what happens when x equals 2? Right, well, we get 20 minus 11 is equal to 0 plus b times 2 plus 1. So we get 9 is equal to 3b. I'm running out of space, but hopefully you're not. So we get b equals 3. So that's one of them. Now substituting x equals negative 1. On the left hand side we get negative 10 minus 11 equals a times negative 1 minus 2 plus 0. Negative 21 is equal to negative 3a, a equals 7. Right, I'm just going to finish off on the next slide to write it out properly. So here's my final answer. I've got 4x cubed minus 3x squared plus x minus 13 over x squared minus x minus 2, and we got our linear factor 4x plus 1 plus 7 over x plus 1 plus 3 over x minus 2. So there you go. Okay, one for you to try. I'll give you the answer in class. We can discuss it there. I want you to figure out this one, 2x squared minus 2x minus 6 over x squared minus 1. So I want you to write that as the sum of partial fractions. Thanks for watching.